Taking question number 5 of miscellaneous exercise of chapter 2, inverse trigonometric functions. The question is, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. Okay, now to solve this question I am going to use this formula. Cos inverse of x plus cos inverse of y is equal to cos inverse of xy minus square root of 1 minus x square into square root of 1 minus y square. Okay, now at the end of this question I'm going to also tell you that how you can remember this formula, and only thing which is required is the knowledge of class 11th about the trigonometric identities. If you know them, you can easily remember this formula. Okay, and next thing which you should be knowing is this, that you can solve this question by many methods, and one possible method could be like this, that you could convert both these cos inverse value into tan inverse, add them and reconvert them into cos inverse. Okay, so this is the formula which is also applicable, or method which is also applicable, but I'm going to solve this question by applying this formula. Now, taking the left hand side, I've been given cos inverse of 4 by 5 plus cos inverse of 12 by 13 and applying this formula. Okay, and placing x as equal to 4 by 5 and y as equal to 12 by 13, I can write this as equal to xy 4 by 5 12 by 13 minus square root of 1 minus x square 1 minus 4 by 5 whole square square root of 1 minus 12 by 13 whole square. Now you can see that this value 1 minus 4 by 5 whole square is equal to 1 minus 16 upon 25, and this will be equal to 9 upon 25, and this will be equal to 169 minus 144 upon 13 square, or 169. Again this will be equal to 25 upon 169. Okay, so this value can be written as 12 for the 48, 5 into 13 65, and this I have shown you that this value will be equal to square root of 9 by 25. This will be equal to square root of 25 upon 169. Okay, so this can be written as 3 by 5, this can be written as 5 by 13. Okay, further I can write this as equal to cos inverse of 48 upon 65 minus 15 upon 65. Simple calculation, denominators are same, so this will be equal to 33 upon 65. 48 minus 15 is 33, so I am going to get cos inverse of 33 upon 65. So this is equal to right hand side, and this is how we are going to prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 upon 65. Okay, now we are going to remember a sort of a trick by which we can always remember this result. Okay, so for this you have to know this formula, cos of a plus b is equal to cos a cos b minus sin a sin b. Okay, now we know that sin a is equal to square root of 1 minus cos a square a. Okay, so I can write cos of a plus b as equal to cos a cos b minus square root of 1 minus cos a square a into square root of 1 minus cos a square b. Okay, so this you have to do. Now further you can assume if that cos a is equal to x and cos b is equal to y. So if we assume cos a is equal to x and cos b is equal to y, so I am going to get here xy, this will be equal to square root of 1 minus x square, this will be equal to square root of 1 minus y square, and here for a and b I can write cos inverse of x and cos inverse of y. Okay, like this, and taking cos inverse of both sides I get cos inverse of x plus cos inverse of y is equal to cos inverse of xy minus square root of 1 minus x square into square root of 1 minus y square. Okay, so I hope that you got an idea that how you can remember. So a and b become cos inverse x, cos inverse y, and cos a cos b becomes xy in this identity. Okay, so this is a trick, or you can, it is also the proving of this result. If we have to prove that how we can say cos inverse of x plus cos inverse of y is equal to this much, then you can use this identity and prove it. Okay, so this is also a sort of proving. But from the day when I have studied inverse trigonometrical functions, I always try to remember the identity which are equivalent to this inverse trigonometrical formula. Okay, so comparing both of them, you can always get the result. Okay, so I hope that this idea would be helpful to you.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.